Hello everyone. Okay, so we're diving into our new unit here. And just a reminder that today in this video, we're covering 4.1, which is Introduction to Reactions. This should all be a review. And 4.4, Physical and Chemical Changes, which again, really should be a review. And so that's what we're gonna talk about in this video. Turn to page 5 for me. And so we're starting with physical and chemical changes and particle diagrams. So we can use particle diagrams to determine chemical and physical changes. And they have lots of particle diagrams in AP Chem. So let's look at this. What if I have a little key here, and let's make a filled in triangle. That's going to be our oxygen. And then let's do a square that's not filled in. That's going to be carbon. Okay? And look at this. What if I have this diagram? Right there. There's one carbon, there's two oxygens. It's carbon dioxide, okay? But just with one single molecule, I can't tell if it's a solid, a liquid, or a gas. And so let me put a few more in here and let's see if it helps you decide. Okay. Now take a moment, fill in the same thing for me on yours. But what is this? Is it a solid, a liquid, or a gas? Like, yes, we know that it's CO2, but of our solids, liquids, or gases, what is it? And I would say that this one is a solid. There's a couple things that suggest this to me. The first is that these molecules are relatively close together. The second is that they're holding their own shape. Notice like this almost. They're not filling up the container. They're not taking the shape of the container. So now, what if it looked like this though? Oops, colored in the wrong side. Okay, so we still have our carbon dioxide here. It's still a CO2 molecule, but now it's a liquid. They're a little bit further apart from each other, and now they're filling the base of the container. They're taking the shape of the container, so this would be a liquid. And then right here, before I try, I want you to pause. I want you to try draw this diagram as a gas. Like, what's this going to look like as a CO2 gas? So our space is even further, and now we're like starting to fill up the whole space of the container. So what do you think? Was the particle diagram above an example of a chemical or a physical change? And this one is a physical change. And the reason why I know this is a physical change, not a chemical change, is because the chemical bonds, these covalent bonds that are holding the atoms together in the molecule, those didn't break or form. The only thing that we really overcame or reduced was the IMFs. Yes, there are attractions between these molecules, and those attractions are the strongest in a solid, and then we overcome, by adding energy, actually, we overcome some of the IMFs, that strength when it becomes a liquid, and then as we add more energy, it goes towards breaking those IMFs or overcoming those IMFs, and then it becomes a gas. And so this is a physical change. Okay, and during a physical change, our strength of IMF can change. Okay. However, so our strength of our IMF can change, but chemical bonds do not. Do not change. So IMFs can become weaker or stronger as we add energy to overcome those IMFs, but the chemical bond itself is not breaking or changing. We see this. We went from like CO2, here's a solid one, so CO2 solid, and this is common where solid carbon dioxide does not go to the liquid phase. Often it'll go directly to the gas phase. It's called sublimation. And this is a physical change, not a chemical change. Okay? Now, what about this? So I'm going to add, I'm trying to think of what would be a good shape. Okay, so we're going to keep our triangle. And this is going to be our oxygen still. And now I'm going to change. I'm wanting something I can like easily add right here, but I guess we'll just do a circle. And then we're going to do a circle, which is going to be the hydrogen. Okay. So here's what we're going to do. I'm going to draw this like before and after. I want you to write the chemical formula. Tell me if you think it's a solid, a liquid, or a gas. And then I want you to tell me if you think it's a chemical or a physical change. Okay? Okay, yeah, we can go with that. All right, so that's what we're starting off as. And then it's going to turn into this. Okay, so what do we have going on here? We have a H2O2. Okay, so we have an H2O2, and they're kind of far apart. They're filling the bottom of the container, so I'd say this is liquid. So H2O2 is hydrogen peroxide, by the way. And then something happens, and notice some of the chemical bonds break and some new chemical bonds form. And we end up with H2 and separate from it, but in the same space, O2. And this time they're spread out from each other. And so this is a gas for both of those. And I would not say that it's both. Like, if you're leaning towards, as I'm hopeful you are on this, a chemical change, I would not say, oh, it's chemical and physical. I would just call it chemical. So it was the particle diagram above an example of a chemical or a physical change. This time it was chemical. Okay. So this time it was a chemical change. And we can see this because this bond and this bond that broke and this bond formed. Okay. But guys, when chemical bonds break and or form, okay, and or form, then it's a chemical change. So a chemical change when chemical bonds break and / or form. Okay, that's a chemical change. And so if I were to write this as a formula, it would be H2O2 liquid results in H2 gas plus O2 gas. That's a chemical change. I also want to point something out because I know it's going to show up on the practice problems. Whether it's a physical change or a chemical change, the mass itself doesn't change. All the atoms that I start with are equal to the atoms that I end with. However, it is possible that you don't perceive mass being gained or lost. And so an example of this is like, what if we're in the lab? We did this with the crucible, like that silver oxide lab. What if we're in the lab and something reacts with the oxygen that's in the air, and then all of a sudden our sample weighs more than it did before? We didn't create matter. It just had a chemical reaction where it took some of the matter that was already in the air and it added it. And so that is something that we can sometimes see with a chemical reaction where mass is like gained or lost, but it's not that it is actually gained or lost. All those atoms were there before. It's just maybe we weren't weighing them before. So I know there is a couple questions that have something to do with that. Okay. So I feel like we've already covered this well, like a physical change and a chemical change, but what I'm wanting from you guys is to write down an example of one, okay? Keep it simple. Think about chemical reactions that you might be familiar with, and I want you in this space to show me a chemical formula that would be a physical change and show me a chemical formula that would be a chemical change. Okay? You don't have to do the same one. Actually, I'm really hoping that you do a different one. But here's an example. H2O solid turning into H2O liquid, an ice cube melted. And just a reminder, because again, I know it shows up in the questions, that when IMFs can be overcome, like the attraction between the molecules, we can add energy and we can decrease, or we could take away energy and we could increase those IMFs, but that would be a physical change, not a chemical change. Where a chemical change is like hydrolysis, like where we take water and we break it apart into H2 and O2. And again, this is usually gases. You wouldn't know that. That's okay. But it's not a balanced equation because all the atoms that we're starting with, there's extra that have shown up on this side. And so we do need to show like, oh, we have 4 hydrogens, 2 oxygens, 2 oxygens. Okay, quick practice. Just circling chemical or physical and what you think is happening there. I will admit that number 2 is probably not drawn the best. Can you add, like, let's pretend that there's space in between here so they're not forming chemical bonds. So this one is chemical, this one's physical, and this one is chemical. All right. So, sure, at the molecular level, it's easy to like look at those particle diagrams and say if something was a chemical change or say if something was a physical change. However, in the lab, we're not able to see the individual atoms. So there are other signs that you need to be aware of that suggest a chemical change has occurred. And actually, this one's not as common, but let's add a 6th one on there. Okay, so we have 3 change in. Okay, so it's going to be 3 of these start with a change in. And then the other 3 are a formation of. Okay, so 3 of these are a change in, 3 of them are a formation of. Okay, let's see if you can think of any of them. Go ahead, write them down, and then let's see if we got the same things. So the one that's most often remembered is a change in color. If you see a change in color, it's probably a chemical reaction. A change in temperature. If you see a change in temperature, it's probably a chemical change. And again, guys, notice I'm saying probably, that like one of these signs alone does not mean that it was a chemical change, but it does mean that it's possible. And the more of these signs that you see, the greater the likelihood it is that it was actually a chemical change. And then this is probably the most commonly forgotten sign, and it's a change in odor. Odor or smell, right? So something can smell like vinegar, right? Like vinegar has a distinct odor. But then when you add baking soda, that like vinegar smell goes away. That would be a chemical reaction, a change in that smell, okay? And then we have 3 formations of. So formation of a gas. Okay, formation of a gas, aka bubbles. If it bubbles, it might be a chemical reaction. Boiling water, though, is not a chemical reaction, and we do see bubbles. Formation of a solid from 2 liquids. Okay. This formation of a solid from 2 liquids has a fancy name, and it's a precipitate. I know that's on at least one of the questions that you're going to be answering. We've done this before, but it's like when we take 2 liquid-looking things and we pour it together, and if it gets cloudy, then that's a precipitate. Or if you take 2 liquid-looking things and you pour it together and it gets like gunky, snotty, slimy-looking, that's a precipitate. And then the last one, which is probably the least common, but still should probably be part of our list here, and it's formation of light. Like if it produces light, it's probably a chemical reaction. Okay, so we're going to save this review for the beginning of class. Thank you guys for taking such good notes, and then we will check these off when I see you in class next time. So like if it's the sub, then we'll probably wait to check off the notes until I get back. But then if I'm there, then we'll check it off. Okay.